Hi guys. So let's look at another problem of determining the molecular formula of a compound when the percentage composition of only one component is given. That is, if only one atom's percentage is given, and you know that there are two types of atoms in a sample. So for example, you are given a sample which we know contains carbon and hydrogen. Okay, we know the percentage of carbon is 92.3%. And we are given the molar mass, which is 78.1 grams per mole. Okay, so we are directly asked to find the molecular formula, but you cannot find the molecular formula until and unless you know the empirical formula. So you have to go through this process. Even if the question is asking you find the molecular formula, you still need to find the empirical formula. Okay, so what is the roadmap? First of all, here is the situation. You know that it's a percentage, first of all. So anytime there is a percentage is given to you, that means that the whole sample is equal to 100 grams. Okay, so in that 100-gram sample, carbon is 92.3%, which means that carbon is 92.3 grams. So out of this 100-gram sample, now find hydrogen. And how are you going to do that? You're going to take the sample weight, which is 100 grams, minus 92.3 grams. And that's going to give you 7.7 grams of hydrogen. That's one thing, 7.7 grams of hydrogen. Okay, so this is first step. Next, this is the first step. Next step is, in this strategy, is to convert grams to moles. Grams of carbon and grams of hydrogen to moles. So we know that we have 92.3 grams of carbon, and this carbon's 1 mole of carbon is equal to 12.011. And always for these empirical and molecular formulas, it's best to write down the mass number as you see in the periodic table. So the periodic table that I'm using, it is 12.011 grams of carbon. Okay, so this is one set. Next is for the hydrogen, it's 7.7 grams of hydrogen times 1 mole of hydrogen. 1 mole of hydrogen, and the weight of the hydrogen from the periodic table is 1.0079 grams of hydrogen. Okay, so when you do 92.3 times 1 divided by 12.001, you are going to get 7.68 moles. And these are the moles of carbon. Next is for hydrogen, 7.7 times 1 divided by 1.00794, and you're going to get here the number 7.60 moles of hydrogen. Okay, after that, once you get the moles of hydrogens and the moles of carbon, you're going to do mole to mole ratio. Mole to mole ratio of each. Okay, so in this case, we are going to see the lowest mole. The lowest moles are of hydrogen. So in that case, you're going to take 7.68 divided by 7.60. So 7.68 for carbon, 7.68 divided by 7.60 for hydrogen. That's the lowest moles. So we always look at the lowest moles to put in the denominator in a fraction, right? In the denominator. So this goes in the bottom. All right, so now we have hydrogen, then we have carbon. The carbon is going to be, hydrogen is going to be 7.60 divided by 7.60, the lowest mole. So this gives you 1.0, and then this one also roughly is 1. So let's just keep it 1 to 1. Okay, so both of them are 1. So now what is the empirical formula? So here is the empirical formula. Empirical formula is the simple whole number ratio. So even though the question may not ask, you still need to do. So carbon 1 and hydrogen 1. So the empirical formula is 1. But in reality, this molecule, just carbon and hydrogen just by itself won't exist, because carbon has a need to make 4 bonds and hydrogen makes 1 bond. So hydrogen might be okay, but carbon has a need to make one. So this is an unstable molecule by itself. However, it just tells us that carbon and hydrogen are 1-to-1 ratio. That is where the molecular formula comes into play, because molecular formula helps you to see the connectivity, the bonds in the molecule, okay, between these atoms. So then next thing we're going to do is calculate the molecular formula. So how would you do that? The molecular formula. Molecular formula is, you take the empirical formula and multiply that by N. Now what is N? N is the formula units by molecule, per molecule. Okay, so what is the formula N? How do you calculate N? N is calculated by taking the empirical formula mass. Okay, and sorry, you're going to take the molecular formula mass, or the molar mass that is given to you. The molar mass is given to you, and you divide that by the empirical formula mass. Divide that by the empirical formula mass. Okay, now let's do this. So we know the empirical formula is CH. Okay, so the empirical formula mass is going to be 1 atom of carbon times 12. Right now here it's okay to just round up a little bit. So times 12, and hydrogen is 1, and this is times 1. So this becomes what? 12, and this is 1 plus add together. So this is 13. Okay, so 13 grams per mole. This is the empirical formula mass, and you are already given the molar mass. And what is that? Molar mass given is equal to 78.1. Okay, so molar mass given is 78.1 grams per mole. Okay, so what will you do? You're going to take the molar mass, the molar mass, or the molecular formula mass, okay, and you are going to divide that by the empirical formula mass, and that's going to give you the value of N. So you have here 78.1 divided by 13, okay, 13 point, actually that's 13.01. Okay, so this gives you roughly 78.1 divided by 13. Okay, so let's do this. 78.1 divided by 13, and that gives you 6.007 and so forth. So you can, drop off this number, drop off these numbers, drop, because we need to simple whole number ratio, and it's okay to round down a little bit or round up at this stage. Okay, so now we have CH times 6. That is a value of N. N is equal to 6. And then that means that it is C6H6. Okay, so C6H6, the value of the molar mass of C6H6 is going to match with 78. And that is going to be how you calculate your molecular formula. Molecular formula is of this compound is C6H6. So even though the question may not ask of you to calculate the empirical formula, you still need to do it. You can't just get the molecular formula right away. All right. So I hope this was helpful and thank you for watching. Bye-bye.